How you guys doing? Sorry I didn't give you guys a video last night. Yeah, I'm still exhausted. Just a little, getting run down a little bit, guys. I still haven't been to the doctor or anything. I'm just trying to rest up a little bit. So I hope you guys understand. But this will be my, like a morning update type of thing. So I will be just going straight to the data and getting into this so people can understand what we got going on. I got a lot to cover. So if you guys could, E-Rock and Della and everybody else in there, thank you for being here. Paul did it. But I am going to go straight to the data. And if you guys have any issues or anything like that, I'll sneak back in here for a second every once in a while. Other than that, I'm just going to get into it, guys. Thanks for being here. Okay, so, guys, we got a pretty big spike in the Schumann right here. This started, well, it's going on for almost 24 hours now. Well, it is 24 hours. You remember yesterday, this thing hadn't updated for a minute, and I was wondering why. Well, when it came back on, all the data was there, but it was this. So, I don't want to say it's like high as far as hurt level goes, but it's very long lasting. We haven't seen a spike like this in a while. And again, it kind of looks like this one over here again too, with it being, how can I put this? It's kind of like a pulse wave type action. So whatever's causing that's causing it. I don't know what is, but there is a spike there. So if you guys felt off all day yesterday, this could have been why. And again, remember, these things are regional. This is not a global tool. All right. So things can happen regionally, like weather, all that kind of stuff. And that's why we have to say that, because we need to understand that this is a regional tool. But usually, let me say this, if we see spikes like this, usually it ends up being something global. The little ones, like that are short-lived, like a 2-hour spike or something, can sometimes be even like thunderstorms. Okay, and that's why we don't make such a big deal about it. But when this is happening here, we most definitely, we know something's happening. So, space weather, it's getting pretty interesting, guys. I have to say, it's and I think this is just going to continue. I think this trend will continue. I don't think it's going to slow down. We might get little lulls, little valleys, but we're going to have more peaks than valleys, guaranteed. So, we're moving into a higher activity. As far as in the solar cycle, we're going to continue to ramp up. But as you can see here, this is our solar X-ray flux up here. This is what we look at when we're looking at flares. All right. And so if you guys remember, if you just think back to my, I don't know, 2 months ago maybe, we were seeing a baseline down here. And it stayed pretty flat. Very seldom did we see anything on this because there were no sunspots. And, for all intents and purposes, we weren't getting many flares either, which usually come from the sunspots. They don't have to be official, but, at least active areas. Now, sometimes we get flares outside of that, I know that, but this right here is a clear indication of the activity on the sun and how it is continually to rise up. And this is a fairly quick rise in activity, guys, and it's staying now. We're going on our 3rd day, and that does, it does make sense because we have sunspots. But as you can see, with our baseline being up here like this, look right here. If our baseline's here, where does that put us? It puts us right there. I mean, we're almost at a baseline at a small C-class flare at all times. Now, it's dipped back down just a little bit, down to probably about halfway into a B-class flare. But look where we were at just 3 days ago. And then we get this spike that spiked up here in the sea, and we all talked about it, right? A bunch of different little flares thereafter, and it still is. But now we have another sunspot that developed, and it looks like it already blew a solar storm at us. So we're going to take a look at that in a minute, because it just happened just a few hours ago. And again, I'm not going to be able to give you a definitive answer on whether or not it's coming at us, but I'm going to show it to you. It's definitely Earth facing. Whether it's Earth directed, don't know yet. We have to wait on some data, but we'll take a look at it. But with this being up here, guys, it doesn't take much of a flare to put us up into M class. All right. And as I was doing this and I was getting set up, I went over here to space weather. Right. So these are the sunspots. Okay, this is the one that's been giving us all the stuff lately, but now we have another one right behind it. 2779, it's official, and look at that thing. I mean, it immediately got intense. I'm talking like with the snap of a finger. So what's spaceweather.com had to say about that, right? Now they're talking this right here. They're talking about the solar storm that could be impacting us on the 1st into the 2nd. That was from the one I showed you guys. It's on the CME tracker. Let me see where's my CME tracker. This one right here. See it? And I've already covered that in my last stream. Now, as you can see, it does hit Earth. So this is what they're talking about. Now the timing of it can be off. They're never exact on this. They're usually off a little bit one way or the other. Sometimes they're off a lot. We just simply don't know until it actually gets here. Until, we got a rough idea. But, guys, I've seen them be off 2 days before. It's been a while since that's happened, but it's happened. So that's what we have to keep in mind. But as you can see, the multiplying sunspots, I mean, look at this. This is, that's pretty intense. I mean, right off the bat, it's a clear indication that that's an official sunspot. I mean, when it pops up like that, there's no doubt. So they already gave it a number. It's there. Okay. And up here it says CME could graze Earth's magnetic field. I'm not so sure about that word graze. And I'm not going to argue that because, number one, if you look at this thing, it's small. So any kind of, change in direction, or not even change in direction, just any kind of miscalculation of what we thought the direction of it would be, would change the impact zone. And if this thing gets changed at all, it could miss us completely, even at that. Or it could bring it right back into right in front of us. We don't, with it being so small, any kind of miscalculation is going to show up at a greater level. So that's why. But then we get down here, right? And this is those sunspots again. Now this is giving you an idea of how big the Earth is compared to the actual size of the sunspots. So if you look up here, in this one here, look over here. This is what we look at on the sun. And this is how big a sunspot is. Okay? But this tells you that sunspot I just showed you in relation to the size of the Earth. Look at that. So these things are bigger, the spots themselves are bigger than our Earth. So it does give you a better understanding and a better, respect for stuff like this. Even though that sunspot isn't, huge all the way across the sun like we've seen them before. This one here actually was pretty big in diameter, or, from one end to the other. The overall size of it was pretty large. Not real large. We're going to see them a lot bigger, is what I'm trying to say. So with that, factor in the size of Earth there. You can put that in there and you're going to be like, oh my gosh. So, yeah. But they even talk about the M-class flares again here, okay? With this thing popping up, it really puts us right underneath M-class flares. We're staying at a C-class. Okay? I mean, it says right here they're crackling with minor C-class solar flares. And they're just barely crackling. You can relate it to, those poppers you throw on the ground on the 4th of July. And they go pop. You give them to little kids. You could compare that to, let's say, an M80. A quarter stick of dynamite. That's the difference we're talking about here. Right? So we're talking about little cracks. And then every once in a while we get that firecracker that just bam, blows right off. And that's what I'm trying to say here. It's not going to take as big of a firecracker to get us into some issues. Okay, now they're saying that this particular sunspot's harboring enough energy to put an M-class flare out. You know, an M class flare could put us into, you know, like a G. I would say, I don't know. You know, usually with a flare like this, you get a CME with it. That CME behind it would probably, you know, it could put us into a G2, a G3, I would think. If we were trying to put a blanket statement across it. But again, that would still vary. It would still matter how much of it actually left the sun. Remember, the actual X-rays from the flare get here in 8 minutes. So, you know, that's quick. Okay, so go back over here, space weather. Geomagnetically, you know, we are elevated a little bit, but we're kind of in the middle, which is okay. Nothing really to talk about there. Now, when that CME gets here, you know, this, I bet we will at least bump up to very active, if not into storm level. Just depends on how intense it is. Now, we've been talking again here, guys. I showed you guys this too. That's an interesting feature. Okay, what makes it more interesting to me is the fact that it has a solar vortex right here. And I'm not sure if that ain't just one big long filament. I can't really see it, so I'm not going to say that that's what it is. But with this being on the end and this area here being a little bit darker, and it runs right into a sunspot, or at least an active area, but it used to be a sunspot, or close to it. So, and remember guys, this up here is the area where we had both of those filaments already released. The big one that happened, it didn't really hit us, it went way over there towards stereo A, and then this other one, which is where we're getting that other CME coming at us, I think is coming from that. At least if it's not, it came from around there. So that's what we're looking at there. Now remember, you know, like a filament release would put us at looking like almost like a halo signature. So that's what we're going to be looking for on that end of it. ACE data, okay, you're seeing the density increase and the solar wind decrease with the temperature. And you're seeing the BZ drop down into negative, which means energy is able to come and flow, all right? The phi angle is doing its little polarity thing, so it's flipping too, so there is stuff here to, you know, consider when we're talking about, you know, geomagnetic storms. Now, something I want to point out here is, you remember guys, yesterday, this was 1 to 10, or 0.1 to 10. Now it's 0.1 to 100. So that means that when we see something way up here, that would be like a 20 or 30 on a data point. And it doesn't look that bad, right? Well, that wouldn't even have hit our graph yesterday. It would have been way up here. So that's what I'm saying with the difference in range. We have to know what we're looking at. That's why we look at that. It changes continuously, and they have to, or they couldn't even graph it. It would be all over the place. But, you know, you got 420 to 560 here. Again, that's only 140 kilometers per second variance. You know, in my opinion, this should be, you know, at least a 200 variance. At the very least. Okay, because we're not talking about a big area here, which is going to make this look a little bit worse than what it actually is. Because it's going to look as if it's moving up and down pretty far, and it's really not. You know, 420 to 560, yes, that's a pretty decent jump. I mean, we could see a difference in geomagnetism with that, definitely. But I still think that needs to be a greater range to give us a better idea visually. But you can see how it's diving off. Now, you know, it goes from 500, like I said, the range, 500 down to 460, so that's only 40 kilometers per second. Not all that much when you think about it overall. Then the temperature is diving off some, you know, which is typically what happens with this other stuff. In little model. This thing here is, yeah, again, it's changing, always, like I said before. Now we got this big hump out here already still. Remember, it was back here. So they kept it, and it's significant. Now, what this is telling us, remember, we're getting that CME between the first and second. So that's what this is showing you. This doesn't predict CMEs or anything like that. All this is doing is showing you density. But the reason why the density is being increased on this model is because of that CME. So that's what we're seeing there. You can even see the velocity itself is going to rise right about the same time. So again, remember what I've said before in the past, that when we get both of them rising at the same time, we take pretty decent hits. And usually that is encompassed around a CME or a solar storm or whatever, right? And this one is related straight to that. So it's easy to point that out. Now, something else I want to point out here. Remember what I said about stereo A? It's taking a hit right now as we're sitting here talking. So it's going to be interesting to see what kind of data we get back from that, because it's taking a direct hit. So that means that we need to look at that and see how powerful it actually was, because it can start giving us clues on to how intense the early part of this new sun cycle is going to be. So, I think it's important to look at that. They're changing these graphs, guys. They're actually making them better. If you look at this one now, see how different it looks? The graphics part of it. I like this setup a little bit better myself, but we'll play it and we'll see it. It does, in my opinion, I think what they've done is they backed down the graphic component of it, but it still gives us a better look. They were going for a more realistic look before they changed to this. And I think this actually gives us a better idea of what we're seeing. I do, anyway. I like the simple stuff because there's no doubt in what it's showing you. When they start making these things, elaborate and they look really cool, sometimes they're hard to read. So keep it like this, and that way we know what we're doing. Yes, this is cool. This is still cool. It's cool enough, is what I'm trying to say. We don't have to have some big 8K whatever to look at, right? But this will give you an idea. Now, we're going to take a look at this when that solar storm arrives. This thing will most definitely, auroras will get down a little further, all that. And depending on the timing of when that thing hits, it would be, if it hits and we're on the dark side, well then, we're not going to get much aurora. We'll get some. Overall, it'll increase anyway, because a lot of it comes in the poles anyway. But if we're on the day side, when that CME, the brunt of it hits, as we get into the darkness is when you're going to see those auroras. So even though, what this is showing you, that's why you don't see nothing on the day side. That doesn't mean that these particles ain't smacking into those oxygen molecules, because they are. It's just there is no aurora on the day side, okay, because the sun's out. That's why. All right? So anyway, electron flux. I mean, I don't know. I can't tell you the last time I seen it that straight. It's kind of crazy, to be honest with you. Now, it's saying it is kind of elevated from zero. So our electron flux is actually kind of elevated, which means there's more electrons hanging around. And what can we compute that to? Well, electrons is what moves from atom, from atom or particle to particle. Each atom, if it's got, extra electrons, or one of those electrons can be bumped off real easy, like with copper, which is why we use it for our electrical wires. It makes it easier flow for electricity. All right, electricity basically is just that flow of electrons. That's what electricity is. So that's why we use certain materials. Certain materials they give up their extra electrons, or those electrons that they have are easily taken away over other material. That's why we use that stuff. In a perfect world, they actually used to use silver and stuff back in the day, but again, it gets expensive. Gold is actually, if you guys get an HDMI cable, a lot of them are gold plated. There's a reason for that. That's exactly what I just told you. Okay, you get better definition out of it because, the electrons and stuff can be moved around a lot easier. It's more conductive. So that's why they use that. Let me check on everybody in here. Is everybody okay in here? You guys, give me a thumbs up or something. Hey, Hilly, when you get off here, bud, check out your email. I sent you something that you're going to want to look at. My jaw was dropped when I was watching it. Okay? Just so you know. Guys, it doesn't have nothing to do with space weather. It's a religious thing, which is why I'm not going to throw it out here right now. So if you check out your email when you get out here, Hillbilly, okay? Hilly Billy. All right. Thumbs up. Cool. Okay. Cool. Sweet, sweet, hillbilly. Sweet. I just want to make sure you see that because my jaw dropped, man. I'm telling you. It was, I couldn't believe what was coming out of that guy's mouth. He's putting himself in a lot of danger. That's all I'm saying. And I'll drop that. I'll tell you guys what I'm talking about here in a minute, but I'm not going to go into it. I'll leave you a link and you guys can go watch it yourself. But anyway, magnetopause. Guys, I mean, we're just getting a little bit of increased activity. I'm not going to waste too much time showing you guys these because there's nothing really much to see. Okay? I went through these a minute ago. Obviously, we still have pressure increase around our planet. It's not going to change anytime soon. It may go up and down a little bit, but when we start getting stuff like this, if it gets starting to get closer to our satellite line, in towards closer to our planet, we'll most definitely have to pay attention because of earthquakes. Okay? In my opinion, that's the single most biggest thing that we can look at that affects people in a really, really large way, significantly, that we can point straight to when we're talking about space weather. Okay? So it's really important to pay attention to earthquakes. You know, I didn't know that back in the past. And, you know, it makes perfect sense. Even, get this, guys, when we have low pressure, that can cause earthquakes too. You want to know why? Because we're not getting held in place like a normal, well, we want to be in normal conditions. Okay? So the Earth and the magnetics are always pushing out to hold us where we're supposed to be, right? So if that pressure around us ain't pushing on us, what happens when it goes away? We're still pushing out. So things can move. And that's kind of what I talk about that a little bit, you know. And I know it's not a huge thing, but it is definitely something we need to consider. Let's go in here. I'm going to back this off a little bit. We're probably not going to look at these here, well, you know, because I'll take you over to seeds here in a minute. But as you can see, not too many like official coronal holes going on right now. You know, we got the northern and southern. It's always there. Okay, so we got a new sunspot, and we're going to take a look at that because it's flaring and it's already blew off a freaking Cme. We'll take a look at it, and I think it's coming at us. I can't say 100% for sure, but we will most definitely take a look at it because it's going to be it's interesting at the very least. Okay, so what I want to do is I'm going to zoom in here. Actually, I think what I'm going to do is I'm going to pull this over here. We'll take a look at this first, and then I can just click over. Okay, so this is the 2778 here. All right, this is the new sunspot. That thing just like appeared and got massive really quick. It got itself put together in a hurry. You know, and I've talked about that before, how we've seen it do that. This one here did the same thing when it was over here. It never went away, which meant, you know, we had to watch it, and because we watched it, we seen it happening when it did happen. And, you know, sometimes that's good, but with flares, it almost don't matter, guys. There is no warning for us when flares happen. You know, there's precursors we can look at and say, hey, you know, we can watch it, which would be a watch. I can't, at any time, I'm not going to be able to come on here and say, hey, guys, you know, hey, we're getting ready to get a flare here in like 3 minutes. I'm never going to be able to do that. One of the main reasons is we have a big lag time with this, right? So, you know, this is not real time. This is close to real time, but it's not real time. I'm going to push play. We'll zoom in here. We'll take a look at this. Because I do think that released. And it happens right at the beginning, too, when that sunspot first appears. So, again, we'll take a look at this real quick. And also, I guess I should probably stop it. I don't know. We'll talk about that in a minute. So, we're going to watch right in here, and I'll tell you when it happens. Probably have to cycle through again. Maybe. Watch right now. See that cloud? You see that what looked to be like a small cloud that happened right there on that side? You can see this thing flare, and then a CME comes out right after it. And again, I'll tell you again when it happens. It's going to happen. There's the flare. There's the CME that comes out. What I'll do, I'm going to, let's do this. It's going to back it up like that. Actually, I'll have to move. So I want to keep you guys zoomed in. That way you guys get a good look at it, okay? But again, here's the sunspot. Now I'm going to toggle this through pretty slow. Okay? And actually, I think I'm going to zoom in a little bit more, seeing how I'm going to do it this way. Now remember, when it flares, it puts out like an X pattern, right? It's not an X flare though. So we're going to see that. Okay, see what it's doing already? Now watch. See that cloud? Alright. So, I mean, it did it. I mean, right away. It was like, bam, I'm here. So again, it's gonna flare a little bit, then you're gonna see a CME come out almost at the same time, because it almost does. You can see, if I back it up, you can actually see this little arm of the umbra that's above it here. And see how it reaches out like that to there, see that? And then on out it goes. And then there is the little shaded area, which is a CME. Okay, now why can't we see it like over here? Well, because the sun itself is blocking us, it's camouflaging it. Okay, we get what we call stealth solar storms, and that's what that is. It's solar storms that actually we can't, it's hard to see. We didn't see them. Neither did the tools pick them up. And that happens sometimes, okay? They're getting fewer because our, people are getting better at looking at this stuff, and our tools are getting better. But as you can see, that happens, right? So I'm going to back off a little bit here, and we'll take a look at it from like this angle, just so we can see it. You'll be able to see that cloud a little bit better. Let me back it back up. And again, this is what I have to say, sometimes we zoom out and we can see a little better. It's going to be right here. I'll just put my cursor there. See that? I'm going to back it up. Now, I do think that was a CME. Now, I can't say 100% that it actually, a whole lot of that left the sun. But one thing I can say is I didn't see any of it go back. Okay? Whether or not it did, I can't say that. Can't say either way, actually. But I do think that left the sun. If it did, if we want to judge by this angle itself, which is all we got right now, I probably shouldn't even be saying this because I don't want to put something out there that people are going to think that they're actually what's going to happen, and it doesn't. But if you look at this, it kind of looks like it's going that way, but that can be deceptive. It's kind of an optical illusion. This is a two-dimensional model trying to represent something that's three-dimensional. So perspective here is key. We're looking directly on it. Now, did that thing actually go that angle, or did it come more like towards us? Like coming right at your face out of the screen? It's hard to tell. I know we're looking at that arm too, moving that direction. But when we see stuff like that, sometimes it shows up as like a halo effect, like I've shown you before with the filaments, like taking the garden hose, and just spinning in a circle, that kind of look. But again, do we need to scrutinize it like that? I doubt it, but I just did. Okay. Anyway, but let's look at the other parts of the sun, because there's stuff going on up here too. Look up here. That actually ejects too, I think. I think it did it before that. You guys see that little glitch there at the beginning? I'm going to pause it. See that? Now, you're going to have somebody out there telling you that that's the end of the world. Okay, but it's not. That is, guys, I mean, that's textbook camera issue. Okay? Now, that camera issue could have been caused by a whole lot of things. I'm not even going to try to say it's one or the other, because honestly, it really just doesn't matter. You know, because nothing really happens on either side of that, so again, doesn't matter. Now, if you look right here real close, you can actually see that line, that brightness kind of shoot off that way too. And what I noticed, and we're going to look at the 211 here in just a second, after we look at the 171, is it actually looked like that energy that happened when that CME happened, like the whole, it like went across the whole surface of the sun. Which is why I'm not sure how strong it is or any of that yet. But this gives you a better look at actually how big it was when it first appeared, because it just did. That wasn't there like 3 hours before this. Okay, now you see it doing its thing, right? Watch how all this kind of spreads out. It'll spread out from that sunspot. We'll go back here. See how the surface, how it grew right across the surface? Now, you know, again, it's still a lot of it went this way, which I think was a CME. See it right there? Bam. But you can see it clearly going across the surface, which is, we see that a lot, right? But we don't point it out. That tells you how powerful these things are. To go that distance in that short amount of time is ridiculous. Remember, I just showed you the size of the Earth, right? Compared to that sunspot. It would fit right there on the tip of my cursor. The Earth would. So when you're seeing these things blow out, I know they don't look that bad when we're looking at it from way back 93 million miles away. Okay, but look what it's doing. Look how far it's traveling in that short amount of time. That's always fascinated me. Now, I know a lot of people are like, why are you talking about that? Well, for the mere fact that just to show you guys how powerful this stupid thing is. I don't want to call it stupid, but, I mean, the power of it's stupid, that's for sure. So, we'll play this one and watch again in the same place. Okay, you're going to get to see that sunspot appear. You guys see that? I mean, come on, man. I was like, wow. So when that thing pops up, watch what happens. I'm going to get you guys back here. Here it's popping up, and it's immediately doing something, right? Now watch the surface of this when that blows. See that? It's like it pulsated 2 or 3 times, and then just like expanded out. Look at that. It actually, if you look close, this one was here before this one popped up. That's a little active area. It's not that big of a deal. But watch it interact with that. See that? You guys see that connection? Ain't that cool? I mean, it's cool in my opinion, but it's clear that we can see that. And that's when that CME happened. So it might have been just the correlation between those two areas that caused it to actually blow. I don't know. But that's kind of what it looks like. But you can see how that energy spread, I mean, all over the surface of the sun. Okay? So, yeah. Hopefully that was, good enough explanation to show you guys how stuff is happening. We cannot just let our guard down for no reason. And, I see a lot of people doing that a lot. But we also cannot go out here and just be so fearful that that's all we talk about is gloom and doom. This is one of those instances that I think we need to pay attention, okay? And I'm being honest about that. And there's a whole lot of reasons for that, and I'll go into it here in just a second. But here's the 29th. You're not going to see much here. Okay, I'm going to take it back to the 28th, and we'll take a look at it there. That's really what we're looking at anyway. So you're seeing it kind of bounce around a little bit. And again, I have to say, guys, this thing used to bounce around a lot more. You know, so it's almost like we're getting compressed all the time now from solar weather, from solar wind, to the point where, you know, because our magnetic field's getting weaker, that we can't overcome it as easy. So when this thing is bouncing around, what I'm saying is, if this thing is able to bounce out to here, that means we're pushing back pretty hard. And we would see it happen all the time. Now it's kind of just hanging out right here. But we know we're getting solar wind. So what's changed? Well, us, guys. That's the only thing that could. You know, if we're not pushing back, that's what's got to happen. That means our magnetic field is getting weaker. And it's all, and we've been saying that for a long time, but that's proof of it. You know, they've been watching it at a micro level, how it's been, you know, getting weaker. And we didn't so much have any kind of clear visual of that, but this is a clear visual of our magnetic field weakening. You know, we can't push back as hard. Geoelectric field model. Okay, you're going to see this thing look like it's doing what it's supposed to do when we get solar weather, right? I did notice we had a spike down here, and I think that's interesting. We'd have to go back in time here because I don't think it picked it up. When I looked at it a few minutes ago, one of the first things I seen was a big blast right here. Why does that matter? I'm going to show you why it matters. This is why it matters. Okay? Hurricane. Now, I'm not trying to claim anything here, but what I will say, almost every time, prior or post or both hurricane landfall down here in the Gulf, we get those big bursts. And I have a hard time thinking that that little circular burst right there that we see in geoelectric field model is coming from space weather every time. So you're left to wonder what caused that. Could it have been the hurricane itself, or could it have been some of the modification stuff that we all talk about, right? I don't know. I'm not going to claim anything here because I don't have any evidence one way or the other. All I can do is show you the observation, tell you what I think, and it's exactly what I think. I think it's kind of strange that we get blasts down here on our geoelectric field model almost every time when a hurricane comes landfall or gets out here in the Gulf, period. We've seen it almost every hurricane this year, guys, if not every hurricane. It's strange. So you guys make of that what you will. I'm not going to tell you how to think. I'm not going to even steer you in any direction. I don't like doing that. But I will say that that is an observation, and it's clear, it's factual that that happens. So I would like to know why. You know, I'm trying to figure out why. But yeah. And again, guys, I wish I could go back further here, but it won't let me. Okay, because earlier, what I got to do from now on when I see stuff like that, and I was doing it like that for a while, I need to just record it. That way I can show it to you guys. And that way, if whatever reason they want to try to wipe it off the net or whatever, I got a copy of it. You know what I mean? I was doing that for a long time, then I wasn't seeing much, and now all of a sudden, yeah. Again, guys, I made the mistake. I let my guard down. And that's what I don't want everybody else to do. So you can clearly see how we're still getting, you know, mainly from the north towards the south. But I think we've all seen the blast that happens down here before. I think most of us have seen that. But it's happening, you know, before and after these hurricanes. You know, it happens outside of those too. But it's too much of a coincidence, in my opinion, that every hurricane that happens, that we see that. Is it the energy from the hurricane, or is it from something else? That's the question. So, seeds, the 27th. Obviously, I've already shown you guys this one. This is when that CME blew off right here. That's coming at us, right? And you see another little, like it picked up something else there. So we'll go to the next day, which is the 28th, and there was another CME. Okay, you see that? It's blowing off that direction. At least that's what this is showing us. But I think this might be the one that's actually on the back side of the sun, because there's one that blew off the backside. So we'll take a look at that in a minute. And why I'm saying that is because watch when this ends. See this time lapse? This is another thing I hate. You know, we get this. This happens, it catches it, and then watch what happens down here. Okay, we go from 1500 to 8 the next day, or in the morning, right? That same day. So basically we're missing 9 hours. From 1500 to 2400. Now I'm sure we can go look at this data somewhere else. It's probably there. We'll go look on this one here real quick. Right here. So let's see. Was that a true jump in time? No, it wasn't. So seeds is the one that's screwing that up. The data's still there. So I'm not going to call it missing data because it's there. It's just seeds aren't showing it to us, right? So if we just toggle that through, we can see, right? Now it is missing some, it looks like. Yeah, it is. No, maybe not. Yeah, maybe not. Yeah, I mean, it's not missing any data at all. So there's that first one there, but then right here on what I just showed you guys down here, that happened at, yeah, like it may not show it because it's that long ago. And keep in mind, you know, even though this says it was like at 5 o'clock UTC, and we can go up here at 5 o'clock UTC, but what we got to keep in mind, the occulter's there. So when this did that on the sun, it would have been behind that occulter. So we couldn't see it anyway. That's what I'm saying. Let me reset this. I haven't looked at this in a minute, guys. This is our radiation belts. Sometimes when we're getting activity, like, well, almost every time, we'll at least get some extra here. Okay. Now this is at the which one is this one? I can't. Let's see here. Yeah, 4,000. That's up high. It's as high as we get. I'm not seeing much there though. Okay. So I'm not going to say anything's getting added there yet. Don't see it, so let's okay, back over here at seeds. I'm gonna start this. That's in reverse. Let's watch it in reverse for a minute, because guys, sometimes you can catch stuff in reverse better than you can going forward. But you can see that clear jump in time. I mean, and again, it's this site. It's not the satellite. If we can go find the data somewhere else, that doesn't mean that it's missing data. What it means is that there's data out there that seeds isn't uploaded yet. That's what it means. So that's why we need to go look at different satellites and different tools to confirm that, hey, that's missing data, or hey, that's what we've seen. And unfortunately, even myself back in the day, I didn't used to do that. I just didn't know any better. But what bothers me is the fact that not enough people do that. So anyway, you got this one here blowing off the backside, and this one here going off the front. So I think what you're seeing here is the one that was showing up over here going off to the side. So let's go to the next day. We'll go to the 29th. And yeah, you see a little bit here. So that might have been the first initial of that other one that blew off the front side. But I think what we're seeing when we're looking at, oops, wrong one. when we're looking at this one, I think that one actually blew off the backside. Okay, because it happened at 1500, and we weren't seeing anything at all on stereo A from the side. So let's look at that on the 28th again. Yeah, that's most definitely what happened. Look, let me back it up. When does this show up? Look at the timestamp. 1524. Okay? So the one we're seeing up here, it looks like it's going to the left, isn't going to hit us at all. This actually is going off the back side of the sun. So if I keep going forward, and it reset. So, yeah. So we're going to have to wait on the one I showed you guys on SDO. This here, the one where it showed up and like it, we can clearly see it right in here, blowing off there. Okay. Over here at Space Weather, we got these red arcing over Sweden. Okay. You guys can go ahead and read this if you want. It's called Stable Aurora Red Arcs, or SARs, that were discovered in 1956. It said at the beginning of the space age. What that means is when we were in space, when we first got there, right? That's when the start of the space age is. It says last Friday in Sweden, photographer Horan Strand saw one. He saw this. It says it was relatively faint to the naked eye. SARs are related to auroras, but they're not the same. That's a key thing here. Okay. Regular auroras, I already told you what they do. They're higher energy particles that come in and hit off certain molecules, or not molecules, but atoms. These, excuse me, they are a sign of heat energy leaking into the atmosphere. Okay, they're caused by heat from Earth's ring current system. So it's heat linking into the atmosphere. That's what's causing this. It says this heat, in this case, may have been delivered by a high-speed solar wind stream that hit Earth's magnetic field shortly before Strand's photo, because that's when it happened. So it's not actually the particles themselves getting in and bouncing off certain atoms. It's the actual heat that's causing these atoms to react. So that's what's happening there. Hopefully I explained that well enough. Earthquakes real quick. I'm not going to spend a whole lot of time on this, but we are seeing, look guys, I got it on 2.5 or better right now. We have, within the past 3 hours, we've had 1, 2, 3, 4, 5, 4.5 or bigger earthquakes. Okay, now when you see the 10 kilometers here, that's a default number. They will eventually go back and tell you exactly how deep they were. These here, they're able to say that already because probably their location and wherever they were at, for whatever reason, they haven't put a depth on these yet. So you can see how we've had a rash of 4.5 or 5s all around the planet. Okay? This one here just happened. That's this one probably. The Tajikistan. Yep. Okay. Now, I'm going to change this because I'm going to dive in here a little bit. So we get this one. These are in Chile. Okay, a 4.0. That's a 4.1. That's a 5.8. Okay, see how that was kind of hidden? And that's why I wanted to show it to you. That's almost a 6. And you can notice how we can click on these boxes here, and it'll take us to the information. I'm not going to spend a whole lot of time on this, but it'll tell you here what we're looking at, right? But you can click on that and go through all this and see how there's a felt box and everything else. That's intensity. PGA, I'm not sure what that actually stands for. I have to look at that. That PSA. Oh, here it is. Peak spectral acceleration. Looks like it's telling you how fast the it moved. It's kind of what it's saying there, I think. So, yeah. Now, again, that's quite a bit of stuff there, guys. So, but I want to show you guys something else here real quick. This. Okay? I think this is important. So, hope you guys can hang in here with me for a minute. Is everybody still there? But what this is, guys, Jesse, okay, is he trying to tell me something? Sure, what's that say? A study of, or just a journalist? I'm just kind of reporting my observations, Jesse. That's all I am. I mean, I kind of got into this a few years back. Just thought I'd keep doing it, just trying to help out as much as I can. Yeah, I've not seen Jesse in here before. Jesse Platt. Did he say anything before that, guys? There's one. No, I'm not a journalist. No way. I'm not. So yeah. So yeah. That's what we'll do here, guys. I'll keep moving. Anyway, you got this being signed into law, guys, and it's our president, obviously. Again, I never thought I'd ever see an article like this in my lifetime. This is a law. Space Weather Act. He did this back on the 21st, and a lot of people not a lot, but a few people talked about this, and so I don't know. I don't know what to feel about this. If this is something that could be, is he doing this now because he wants to do whatever, right? But you guys can read this. It says, my administration will treat these limitations as advisory and non-binding. Okay, they always say that. And so, my gosh, it's just saying, hey, I don't want no responsibility for that. That's what that's saying. Additionally, space weather can have devastating effects on national security assets, and he's right. Okay, but this is the most important thing here: nation's critical infrastructure, including assets in space. Okay, and that always brings up the question: what kind of assets do we have in space? And we know about satellites and all that other kind of stuff. But what else do we have up there, right? But what he's doing here is the Act provides authorities, to improve the gathering of space weather data and the forecasting of space weather. However, that certain provision of the Act will generally unobjectable as a matter of policy could limit my discretion under Article 2 of the Constitution to conduct the nation's foreign affairs. So he's doing this. He's giving, basically what it is I bet this is a precursor to them being able to open up funds to add to these, basically Space Force, that kind of thing. It's just my take on this. That's all. If you can go look at this yourself, make up your own mind. This is not the actual law itself. This is the article. This is what the White House had put out on what he did. You can just type S.881 Space Weather Act, and you'll find exactly what the act is. Yeah, exactly. For them to know, for us to find out, that's for sure. But yeah, so we got, like I said, guys, I don't want to go too much more into this or waste everybody's time. You know, if you want to read the whole thing, and it's not extremely long, but it is kind of lengthy, which is why I'm not going to sit here and read it to you. The law itself, the act that he signed. But Congress, everybody already approved this. This is actually in law now. So my guess is this is just like an extension of the Space Force, giving it, you know, being able to allocate them funds to do stuff like this. That's just my opinion. You know, obviously I can be wrong on that. But there was something else here too, guys, I wanted to bring up that I haven't brought up yet. And you know, this is kind of old news. I don't call it old news, but it's the 26th, okay? Obviously, it's the water on the moon, okay? For the life of me, I cannot understand why people think this is such a surprise. I just don't understand that, guys. I mean, I'm serious. I mean, why is it such a surprise that we found water on the moon? I mean, what's so, I mean, come on. So, yeah, you guys can read this article or whatever you need to do, but they found water on the moon. I'm not going to go into detail, but this is actually from the NASA.gov site. So, I don't know. And I think what's going to happen is that, you know, we're going to find out that there's water on almost everything. And I think we would be very, very naive to think else of anything else, you know. I'm sure there's planets and stuff out there that don't have water. I get it. But let's go, you know. Come on, let's be real about this. There's going to be water everywhere. And I know what that does. And the reason why this is a big deal, because nobody wants to, like, entertain the fact that there possibly could have been life elsewhere. You know, the thought process behind this is that if they didn't find water, that would eliminate the possibility of life. That's why they talk about this. And, you know, I don't know. Whatever your belief is on the background of that, you know, and obviously it's going to be influenced probably a lot of people by their religious beliefs and everything else. I get that. But I would say that just because we found water somewhere does not necessarily mean any of it. That's what I would say. So, anyway, guys, I think that is probably what's going on. Again, you know, I really don't have a big opinion on this because, I don't know, obviously we get told that that's probably not what was going to happen, and this is going to fuel a whole lot of different genres of people doing research. It's going to give them a whole lot of fuel to go really, really deep in some rabbit holes. I would assume. Okay, and so why I say that is I would caution yourself on what you're listening to and what you're going to believe on this, and what this could actually cause, because we all know that it's a possibility of anything when you find water anywhere outside of our planet. Okay, it's always a possibility, but what we forget to do is check out the likelihood of it, kind of like an Occam's razor mind of thinking. Okay, so you know that is what it is. Is the water under or on the surface? That's a good question. I think it was under, if I'm right on that. Anybody know? Yeah, okay. Yeah, it was under. And I think that's kind of the theory, guys. If people want to know, the theory would be, you know, if we can't see it on the surface, well, it doesn't mean that it ain't under. You know, and there's a lot of people think that space weather brings water. But okay, but you know that's kind of what I'm saying. So I don't know, you know, as far as getting all detailed on what's going on with this and what this could actually mean. For all of us down here doing what we're doing, it's probably not going to mean a whole lot throughout our lifetime. Maybe in future lifetimes, maybe. You know, I don't know what we can do with this in a short time. And yeah. So yeah, that's it's kind of what I think, you know. But again, that is all opinion. Take that for what it's worth. And that's where I'll leave that, guys, because, you know. Let's see here. Anybody got any, yeah? Okay. I can see where that conversation is going to end up. It's probably going to end up in a huge, huge argument. You know, guys, just be careful with each other in there, okay? Just be cordial. It's okay to have a different opinion. And I haven't seen anything. Hey, written in the stars, that's the kind of stuff that, you know, right there, that actually it's kind of gaslighting when you say stuff like that. Okay? I'm trying to be as nice as I can, guys. And this is why I try to steer away from these kinds of conversations. You're right, Jay Banks. That's what I'm trying to say. You know, we can have disagreements, we can disagree, but when you make statements like assuming that somebody is under a spell, that's an assumption. There's absolutely nothing you could do to try to prove that he's under a spell. I know you don't, written, and that's kind of why. If I thought you were doing harm or trying to, you wouldn't be talking to us anymore. You'd have been banned or timed out or whatever. I get it. I really do. Yeah, we do get lied to a lot. And again, that's where the difference of you know, we can just like disagree on certain things and still be okay with each other, you know? So thank you guys for being like that anyway. I really do. I appreciate that. You know, sometimes we just get into such a, you know, a lot of the stuff that we're passionate about, we really get polarized on it. Hey, VW. And I appreciate each and every one of you guys that take the time to come here and listen to this stupid dude talk. And yeah, exactly. You did it right there. Praying hands. Exactly. So, you know, and I know that Hilly's not trying to come at nobody either. I know him. You know, we've known each other for years. And that's kind of the thing, you know. If we can just go with the flow, tell our opinion, and listen to somebody else's with the open mind that we want them to listen to us with open mind. You see what I'm getting at? And so that's what I would say. I don't really want to go too much more into that because it's going to make this video really long, and that's the point of not. This video is to give kind of a daily update. So I appreciate all you guys. Thank you guys for being in here. I really, really appreciate what you guys come here and listen to me. And hopefully I can help in any certain way, at any level. And so yeah, and I will be back later on tonight with a live stream that's going to be more laid back. Okay? So thanks to all the mods. Thanks for everything that you do. Della, Arizona, Hilly's still in here, I think, E-Rock. Anybody. And plus all of the subscribers. So I would appreciate it, guys. I appreciate all you guys. God bless. Yahuwah saves, and